to present a few notes which align to objects that are positioned in equilibrium, limiting equilibrium, you name it. And after I'm done with the explanations, then in the next series, we'll dive into similar questions that you'd find using the concepts explained. I hope you find this interesting. Right, so I'm starting. The idea here is to treat what we call objects on an inclined plane. Right. See how the story goes. Mute my mouse so that can properly scroll. Um, let's see. Let's see. Right. Let's have a look at this scenario. If I have an object, I'm going to use a small rectangular box to represent an object. Now, if this object is resting on a horizontal plane, these are various forces that might be acting on the object. We have what you're going to call DF. That's the driving force, which might force this object perhaps to move in a given direction. Now, depending on the surface, if the surface is not smooth, then we expect to have an opposing force, which is friction. To add on, if the object happens not to be bouncing up and down, we might have also another force, which we call the normal contact force, normally referred to it as N, or sometimes it's referred to as R. That's normal. This force is always perpendicular to the surface and it acts upwards. But depending on the mass of the object, below we will have a force that we refer to as weight, which is calculated as mg, where this is a product of mass and acceleration due to gravity. Yeah, in exact form, g is approximately 9.8 meter per second squared. That's acceleration due to gravity. But for simplicity, in our subject, we are going to treat g equal to 10, because what we are interested in are mere calculations to say if we want to solve a problem, maybe we're interested in looking for friction, or we want to know the driving force. Sometimes it's the weight, you name it. For simplicity, we might take 10 just as a rounded figure. So the concept here is when we have, instead of the object resting on the horizontal, no, the surface is going to be tilted such that it's inclined now by an angle theta. And when this happens, I'm going to position an object here to say with this object, initially the weight was supposed to be perpendicular to the plane or the surface again. But we define weight as the force with which an object, it's the earth which pulls on an object. In other words, the earth is trying to draw an object towards its center. So if we tilt an object, the weight is always facing downwards. So with our initial surface, it will be perpendicular. But because we tilted, now there is a change to say we're going to create a right angle here, where this theta that we see will also be found here as our weight moves away from the perpendicular to the surface or the plane. But the normal contact force is always perpendicular to the ground. So we expect our R to be here. Then, when I created my right angle triangle, I'm going to come up with components. For instance, this uh, parallel component, when I say parallel, I'm referring to the plane or the surface. Parallel is going to be W sine theta, because our weight is here. And this perpendicular is going to be W cos theta. And if you can check carefully from this explanation I'm giving, if we agree that this object is not bouncing, then what it means is R, the normal reaction force, is going to be equal to W cos theta if the object is not bouncing. But remember, last time we spoke about driving force. This might be a force which is holding an object, sometimes stationary, because as long as we are tilted, this object has got natural tendency to slide downwards, especially if the surface or the plane is smooth. But let's say it's rough, then we will expect to have frictional force, which is opposing motion. But now, if we check carefully from this right angle triangle that I have, which gave me the parallel and perpendicular component of the weight. We can see clear that the friction and the parallel component of the weight, they are facing the same direction. So I'll be allowed to say we also have two forces, friction and W sine theta. Now, depending on the magnitude of the driving force, sometimes it might be uh, lesser than the weight component. Now, if it happens that weight, which is W sine theta, is bigger than the driving force, then what it implies is the object is going to move down the plane. So it will slide downwards. And remember, we said um, friction is always opposing the direction of motion of the object. So if weight comes to be bigger in terms of magnitude, if weight is bigger, then the object will go downwards. Hence, friction will face the same direction as the driving force. Now, if it happens that driving force is bigger than the weight component, which is W sine theta, then the object has tendency to move up the slope or upwards. Right. I've got a new term which is friction. Friction there, and friction is defined as the force opposing motion. So friction has got its formula. If we want to calculate the magnitude of friction, it's calculated as mu r, where mu is coefficient of friction, which is normally found in the interval 0, let me call it mu here, 1. It's allowed to take 1, can take uh, closer to 0, but if we say friction is 0, it means there is no friction. In other words, the surface is smooth. If friction is maximum, that is at 1, it means the object is likely not to move because we have reached the maximum magnitude of friction. So with this that I've said, I just want to treat three questions, and these three questions, I hope you find them interesting or inciting. But a recap check, that's a free body diagram for objects on an inclined plane. We spoke about the magnitude of G. We want to find weight. We also looked at the normal force, and there we are. And we agreed that if the object is not bouncing, what it implies is and the reaction force, it will be equal to the perpendicular component of weight. So that was it on the explanation about objects on an inclined plane. We spoke about limiting equilibrium to say, depending on the magnitude of either weight or the driving force, it tells which direction the object is likely to move. Thank you.